titrations. Now, before I start this video, why am I going through these practicals? I want to really stay consistent with these practicals, so I'm going to be posting a lot of practical videos of these over this half term, these current 2 weeks, because practicals and exam, they can be like 10 marks worth of practical questions, maybe even more. Paper 3 is a lot about practicals, and I just want to start early with the practicals, so before, like, if I can consistently stay with it, I feel like I'll know them really confidently before the exams happen, so then I won't have to worry about practicals. So titrations need to be done accurately. Why is the flask on a white tile? Because it's done on a white tile, it's easier to see where the exact endpoint is. Why is the universal indicator no good? The color change is too gradual. Therefore, the two main indicators for acid-alkali reaction is not going to be a universal indicator because it's no good because the color change is too gradual. It's going to be methyl orange, which is red in acid and yellow in alkali. Phenolphthalein, colorless in acid, pink in alkali. Methyl orange, red in acid, yellow in alkali. Phenolphthalein, colorless in acid, pink in alkali. Why are these two indicators used? They change color quickly over a small pH range. Now, what does that mean? They change color quickly over a small pH range. Well, it means therefore we can know exactly when the reaction ended. Why do you add acid dropwise in endpoint stages? So we can see exactly when the color changes and therefore the results are accurate. Why is a rough titration done? To find where the endpoint is, aka the exact point endpoint, the exact point where alkali is neutralized, aka the indicator changes color. A rough titration to find out where the endpoint is, exact point where alkali is neutralized, the indicator changes color. You want to add acid to alkali using a burette, flask, a regular swirl. What? And then I think I couldn't be bothered doing the rest, I'm pretty sure, because that's why there's nothing else. What is an accurate titration? Titration, initial reading to see how much acid is in the burette. Then we want to run acid into 2 centimeters cube of the endpoint, and the endpoint stage we add dropwise, so we can see exactly when the color changes, therefore the results are accurate. And then we can work out the amount of acid used to neutralize the alkali, and the titer is final reading minus initial reading. Why must when you use a funnel to pour acid into burette below eye level? Avoid any acid splashing into face/eyes. Ready to titrate, you want to use a pipette to measure set volume of solution. So we can know the concentration of. To measure set volume of solution, we know the concentration of. Put into a flask. Add drops of an indicator to flask. Methyl orange, phenolphthalein. Methyl orange, red in acid, yellow in alkali. Phenolphthalein, colorless in acid, pink in alkali. Fill a burette with a standard solution of acid. Use a funnel to pour acid into burette. Titrate. Titrations are used to find out the concentration of acid/alkali. Titration allows you to find exactly how much acid is needed to neutralize an alkali quantity. A standard solution is required before you do a titration, and the standard solution is any solution you know the exact concentration of. How to make a standard solution? Dissolving a known amount of solid in a known amount of water to create a known concentration. This is how you convert centimeters cubed to dm cubed, centimeters cubed to dm cubed times by 1000, dm cubed to centimeters cubed divided by 1000. I think because in exam questions, they like you to convert units when doing the titration calculation questions. Now, that's obviously a simple version, but this is how you actually make a standard solution. So we want to work out the moles, concentrate times volume of solid. Then we can work out mass in moles times mol of solid. Then we want to place a weighing bolt in a digital balance to 2 decimal place and weigh out the mass of solid. We want to tip in beaker, and we want to re-weight the bolt, which still contains traces of solid. Subtract mass of bolt from mass of bolt plus solid. We can find out the precise mass of solid used. And then we want to add distilled water to beaker or deionized water to beaker and stir until all the solid has dissolved. We want to tip solution into a volumetric flask, and we want to use a funnel to ensure it all goes in. We want to rinse the beaker and stir water with distilled water or deionized water. And we want to add to a flask, and we want to make sure no solute is clinging to the beaker/rod, I think that says. And then we want to top flask up to correct volume with more distilled water. The bottom of meniscus must reach the line, and then stop at the flask, turn it down so mixed. And then I think we invert it at the end. And that's the end of this practical.